Hello viewers, in today's session we are going to discuss another important problem from indefinite integrals, right? So here in this class we are going to evaluate this integral in which we have to find the indefinite integral of this function, that is cosine inverse 1 over x, right? So to evaluate this integral, we'll make use of two important concepts. So the first one is integration by substitution method, and then we'll apply the concept of integration by parts. So let us call this integral as I, right? And here we have cos inverse of 1 over x. So let us make this substitution, that is cos theta is equal to 1 over x, right? So why we have taken this substitution? Because see here our integrand, say f of x is cos inverse 1 over x. Now when we take 1 over x, then we have cos inverse cosine of theta, and from the inverse trigonometric functions we can write cos inverse cos theta is equal to theta, right? So f of x is equal to theta, where cosine theta is equal to 1 over x. So here we can cancel this cosine inverse and cos by definition of the principal value branch of cosine inverse function, right? So we'll make this substitution, and now we can write x is equal to 1 over cos theta, and 1 over cos theta is secant theta. So we have x is equal to secant theta. So now let us differentiate x with respect to theta. So we have dx over d theta is equal to the derivative of secant theta. So the derivative of secant theta is secant theta tan theta. So now the value of dx is equal to secant theta tan theta d theta, right? So now we can rewrite this integral I in terms of this new variable theta. So we can now write integral, and cos inverse 1 over x is equal to theta, and for dx we can now write secant theta tan theta d theta. So now this integral is reduced to this one with the help of this substitution. So now to evaluate this integral, we'll make use of the method of integration by parts, right? So let us first see the formula for integration by parts. Suppose we have two functions of theta, then we can write the product of the two functions u and v, and here we have d theta. So suppose u and v are functions of theta, then the integral of the product of the functions u and v is given by u. We can take u as the first function, then v as the second function. So we can write u multiplied with the integral of v, and then we have integral, then we have the derivative of u with respect to theta, and then here we have the integral v d theta, and then this entire term is integrated with respect to theta. So this is the formula for integration by parts when we have the product of two functions. So now here our integrand is theta times secant theta tan theta. So what we will do, let us frame u and v from this function. So we can take u as say theta, and v as this function that is v, because we know that the integral of secant theta tan theta d theta is equal to secant theta, right? So now taking u as theta and v as secant theta tan theta, we can now substitute the value of u and v in this result. So our integral I now it becomes theta secant theta tangent theta d theta is equal to u is theta, then we have integral v d theta, v is secant theta tan theta d theta minus integral, and then we have the derivative of u with respect to theta, u is theta, and then we have secant theta tan theta d theta, and then here we have d theta. So now this integral is equal to secant theta. So we have theta times secant theta minus integral. The derivative of theta with respect to theta is 1, and the integral secant theta tan theta is equal to secant theta, right? So here we can write secant theta d theta. Now, from the standard results of indefinite integrals, we know that the secant theta, the integral of secant theta is given by a log of sec theta plus tan theta, right? We can also use this result also for integral of secant theta, that is log of tangent of pi by 4 plus theta over 2. So we have two results for the integral of secant theta. So here we'll prefer this result, and we have I is equal to theta secant theta minus the integral secant theta is now equal to a log of secant theta plus tan theta, and here we have the constant of integration as c, because we are dealing with indefinite integrals. So now this result is in terms of theta, but our original integral was in terms of x. So let us convert this result in terms of x by using this result, right? That is x is equal to secant theta. So here for theta, we can write theta is equal to cos inverse of x, because here we have theta, that is cos theta is equal to 1 over x. So theta is cos inverse of 1 over x from this result, right? So here we have cos inverse of 1 over x, and for secant theta we have simply x and minus log, and for secant theta we have x, and for tan theta we can use this standard result from trigonometry, that is 1 plus tan square theta is equal to secant square theta. So tan theta is equal to square root of secant square theta minus 1. So if we take secant theta as x, we have x square minus 1. So for tan theta we have square root of x square minus 1 plus c, right? So the value of this integral is given by x times cos inverse of 1 over x minus log of x plus square root of x square minus 1 plus c. So for this term we can use the inverse hyperbolic function, and we know that the inverse hyperbolic function of cos x, that is cos h inverse x, is equal to log of x plus square root of x square minus 1. So the inverse hyperbolic function of cosine x is given by a log of x plus square root of x square minus 1. So here we can replace this log term by the inverse hyperbolic function, and here we have c. So the value of this integral can be taken as this expression or this expression. So viewers, if instead of taking the integral of secant theta as log secant theta plus tan theta, if we would have taken the integral of secant theta d theta as this term, then we would have theta secant theta minus a log of tan of pi by 4 plus theta over 2 plus c, right? And then secant theta is x and theta is cos inverse of 1 over x minus log tangent of pi by 4 plus half. For theta we can write cos inverse of 1 over x plus c, right? So in that case, if we would have taken this result, then our the value of this integral would have been x cos inverse 1 over x minus logarithm of tangent of pi by 4 plus half cos inverse 1 over x plus c.